this shape that I just outlined has exactly one set of parallel sides, so we know this is a trapezoid. And I have two trapezoids here. There's this one, and then there's this one right here. Okay? It's kind of the same idea as Riemann sums. You find the two areas of these trapezoids, add them together, you have a rough estimate of what the area under the curve is. And you remember what we learned with Riemann sums? We learned that if we have a lot of rectangles underneath the curve, then we have a more accurate estimation of the area. So the same actually applies to this. See, there's two trapezoids, there's three trapezoids, there's four trapezoids, five trapezoids, 6, 7, 8. So we got 8 trapezoids. And actually, it looks like it almost fills all the area underneath the curve. There are some points where it slightly sticks out, like right here and right here. But this would be a good estimate, would it not? So if you just wanted to just know the very basic, the bare bones of the trapezoidal sum, whatever, you just have to find the area of each of those trapezoids and add them together. But you have to know that the sides are your bases. Like this is a base, and this is a base. And you have to know the formula to find the area of a trapezoid. Ooh, you guys remember that? Okay, let's write it. Let's go. A of a trapezoid equals 1/2 times base 1 plus base 2 times height. So my base 1 is there, base 2 is there, or you can do opposite, it doesn't matter. And then what's my height for that trapezoid that I just traced? Here, I'll finish tracing it. What's my height going to be? The distance between here. That would be your height. It's kind of weird, huh? We know that as delta x, or just b minus a. Actually, my b is right here, so I can't use b. But anyways, it's the difference between those two x values. So let's try a problem, shall we? Let's try. No, wow, I got lots of trapezoids in that one. Let's try this one right here. So the problem says use a trapezoid sum to approximate that zood, where f has values as given in figure 4. All right, there's your table. Do we know what the function is? Nah, we don't. Okay, do we know how many trapezoids we should do to do this?
No. Yeah, no. We don't know the function.
It doesn't tell you, huh?
Yeah.
But it does give us points. It gives us these points. So if we want to be accurate in our estimation, we need as many trapezoids as we could possibly make. So how many trapezoids could we possibly make with this table? I can make one trapezoid between these 2 points. That's 1. And these 2. That's 2, 3, 4. It looks like I can make 4 trapezoids. Let's try to give ourselves a visual. The first 2 points gives us a really clear visual. Let's see. We have x equals 1. So I'm going to put a 1 right here. And it goes up to 7. There's 7. So this point goes up here. And then my next point is 2. And that goes up to 4. No, I'm sorry. That's not 2. I mixed it up. It's 4. That's my x value. And then my y value is 2. So I'm going to go up to 2, which would probably be right about there. I don't know. It doesn't have to be perfect. And if I make this trapezoid, this is what I got. That's a clear trapezoid. Huh? All right, let's do our next point. What's our next point? Our point says 6, negative 1. So I have 6. And we're supposed to go down to negative 1. Well, that's weird. So I go down here to negative 1. Well, that actually looks kind of confusing. Like, how do I make a trapezoid of that? You know, that's like 2 triangles. It's not a trapezoid. All right, let's do our next point. It is 3. No, it's 9. It goes up to 3. So 3 is right about there. Let's put 3 right here. So that doesn't look like a trapezoid either. Look, it's like this trapezoid got folded over the x-axis right there. And then the last one is 10. I'm just trying to get a visual here. You don't have to be able to do this. All right, look at that. That's a nice trapezoid. All right, cool. What I want to do is I want to find patterns and just find our answer that way. All right, you guys ready? Let's find the area of that first trapezoid. Here we go. 1/2 base 1. What's the length of base 1? 7. Yeah, let's do this one right here. I'll call this my base 1. That is 7. Plus, and what's the length of my next base? 2. Hey, 7 and 2, what are those pretty much? Just these y values, huh? Okay, that's the length of the sides. And so, and then I have to multiply it by the height. What's my height of this trapezoid? What's the height of that? 3. So go 4 minus 1, you get 3. So I have 3. And then, okay, so that's the area of the first trapezoid. Okay, cool. So let's copy that. Let's do it again. We have 1/2 times the two bases. We have to add the two bases together. And so what's my first base going to be? 2. And then my second base, let's look at our y value since we pointed that out. What is that? -1, okay. And then I have my height. What's my height between 4 and 6? It's 2. Oh, wow. Okay. And then let's do our next one. We have 1/2. Base 1 would be this one right here, right? The -1, because we already did the 2. So we have -1, and then we're going to add to that a 3. That's our other y value. We're just going to keep following this pattern, right? And then we're going to multiply that by 3. How do we get 3? 9 minus 6. 9 minus 6 is 3, right? And then we have one more trapezoid. Okay, 1/2 times. We have 3 as our first base, and what's our last base? 5. Okay, and then my height there is 1, because 10 minus 9 is 1. Okay, did you guys see all those patterns? Okay, now there's certain things we can do to kind of simplify our lives. Now this one only has one thing we could do, which kind of stinks. I can take out from this a 1/2. I take 1/2 out from all those. So we can just save the 1/2 all the way till the end and then multiply everything by 1/2, or multiply my result by 1/2. Let's see, that would be 7 plus 2 is 9. 9 times 3 is 27. Plus, and then we have, get a 1 from that times 2, so we just have a 2 right there. And then we have, what is -1 and 3? That's 2 times 3, which is 6. Plus, and our last one is going to be an 8. Let's add these guys up, and we're going to multiply that by 1/2 when we're done. See, 27 and 2 is 29, plus 6 is 34. No, 35, right? Plus the 8, 43. So I have 43 times 1/2. Our answer, 43 divided by 2. I mean, you can write 21 1/2, but you don't have to simplify it. If you don't have to, don't do it. Oh, I wanna make a general form for using the trapezoidal sums. I think this is really cool. I'm sorry, I'm gonna nerd out on you guys. Here we go. Let's first find the area of this first trapezoid. Here we go. We have 1/2. First it's 1/2. And then we go base 1 plus base 2, right? Okay, but how do we do that? How do we represent the base 1 and base 2 for that trapezoid? Because we don't have any numbers. Well, first we're going to have to define this function. We have to give it a name. Okay, I'm going to call this curve f of x. All right, so x naught is going to be our first x value right there. And so if I plug in x naught into that, won't that give me the y value that I need? Yeah. Okay, so I'm going to plug in, I'm going to go x naught into my f. And then I'm going to subtract the next base. So how would I find the length of this guy right here? Oh, we're going to need an x value right there. What are we going to call this x value? X sub 1.
It's adding, right?
Oh, adding. You're right. I'm supposed to add. See, you guys are paying attention. That's good. I was just checking.
Yeah,
Okay, so that's base 1 plus base 2. And then what am I supposed to multiply that by? The height. And the height is going to be the difference between x naught and x1, right? It'll be the distance between those two. You guys okay with that?
yeah.
Okay. So I'm going to say x sub 1 minus x naught. Now this is looking pretty nasty. What's the next thing? What's the next trapezoid going to look like? Or let's do it one more time, and then we'll start simplifying it before we get to the end. Okay, we have 1/2, and then now we're looking at. I should probably do a different color. Let's do red. Okay, what is the first side? How am I going to find the length of my first base? F of x sub 1 plus the next side. So if I finish tracing this, we can see that this other side is this one right here. Okay, how am I going to find the length of that one? F of x sub 2. Okay, and then what would the width be, or the height be for this trapezoid?
x2 minus x1.
x2 minus x1. Wow, this is getting nasty. Dot, dot, dot. We're going to keep doing that. Okay, but let's make this look a little nicer. Now, I'm just curious. Do you guys think all these heights of each of these trapezoids are the same width? They look the same. So I'm going to assume that they are the same. And you can only do this if they are the same. I'm going to, instead of writing these guys, I'm going to write delta x. So delta x equals these. That's the change in x between those two. Is everybody cool with that? Okay. Now, both of these have a 1/2. And you agree that every other trapezoid that we find the area of will also have a 1/2. Okay, so I'm going to take out a 1/2 delta x. But instead of writing it like that, I'm going to write delta x divided by 2. All right, is everybody still with me? I'm going to factor that out. Now I'm going to use these big old brackets right here. So pretend I had big old brackets right here, and I factored out the delta x and the 1/2. You guys see where I'm going maybe?
Yeah.
Maybe. Okay, now watch what I have now. I have f of x sub 0 plus f of x sub 1. Now, do I need to put parentheses around these two guys right here? Am I multiplying anything inside? Like, I know I'm going to multiply this delta over 2, but there's nothing I'm multiplying to those particularly, so I can leave the parentheses off. And then I would go plus, that's that plus sign right there, whatever's over here. What f of x sub 1 plus f of x sub 2, f of x sub 1 plus f of x sub 2. Now, I'm trying to look for shortcuts so that I don't have to keep writing things. Do you guys see it? Combining like terms? Yeah? Okay. Yeah, you sure?
Yeah.
Check it out. Delta x divided by 2. We have f of x naught plus 2 f of x sub 1 plus 2 f of x sub 2 plus, what do you think would be next? 2 f of x sub 3. Now, so I don't have to keep doing this, what would be my last one?
F of x sub n.
All right. So you got f of x sub n. That would be the last one, huh? That would be the last one. It says right there. Shebang-a-dang. You guys see that? That's cool, huh? General form right there. And actually, to make this more precise, like more formal, I would say 2 f of x sub n minus 1, just to be annoying, plus f of x sub n. And that would be it. That's how you do a trapezoidal sum.